Warm welcome to the Green Tech Goals channel, where we uncover the latest technologies that aim to safeguard our precious planet. Today, we're going to explore a groundbreaking study by Dr. Hamidreza Samoué. Dr. Samoué, a researcher at Texas A&M University, has been delving into the hidden treasures found in an unlikely place, produced water. This is a waste byproduct from oil and gas operations. Now, you might be thinking, wastewater, really? What could possibly be so exciting about that? Well, brace yourselves, as Dr. Samoué's research reveals that this produced water, this waste, contains nearly every element in the periodic table, including critical minerals of great interest to national economies. Yes, you heard that right. Minerals like lithium, rubidium, cesium, gallium and platinum group metals, along with abundant quantities of sodium, potassium, magnesium and calcium, are all hidden within this seemingly unassuming wastewater. Stay tuned as we dive deeper into how this discovery could revolutionize the way we view wastewater. Don't miss out. Subscribe to Green Tech Goals. Imagine if wastewater could become a source of critical minerals and fresh water for agriculture. It's not a dream, but a reality in the making. To grasp the scale of this potential, let's look at the global quantity of produced water. This is a byproduct of oil and gas operations, and in the year 2020, the world saw more than 240 billion barrels of this water recovered. That's a mind-boggling amount of water, isn't it? Now let's narrow our focus to Texas. This one state alone recovers 33 million barrels of produced water daily. And the oil fields of the Permian Basin in Texas, they generate more produced water than all other US shale plays combined. But what makes this water so special? Well, it's what's inside it. Produced water contains nearly every element in the periodic table, including critical minerals of significant interest to national economies. We're talking about minerals like lithium, rubidium, cesium, gallium and platinum group metals, not to mention abundant quantities of sodium, potassium, magnesium and calcium. In fact, these minerals can be more lucrative than the oil recovered with the water. Yes, you heard that right. The wastewater from oil and gas operations could potentially be a gold mine, offsetting water reclamation costs and turning a waste product into a valuable resource. In the next chapter, we'll explore how carbon dioxide can be used to treat this water and recover these valuable elements. Make sure to subscribe to Green Tech Goals to stay updated. The future of our planet may well depend on innovations like these, and you won't want to miss what's next. Turning waste into wealth is the new gold rush. Let's delve into how CO2 can be used to treat produced water. Picture this: billions of barrels of produced water, a byproduct of oil and gas operations, containing nearly every element in the periodic table. Yes, you heard it right, nearly all of them. But this isn't just any ordinary water. It's a reservoir of untapped potential, a treasure chest of elements critical to our national economies. Now, meet Dr. Hamidreza Samoué, a researcher at Texas A&M University who's on a mission to unlock this treasure. Samoué's approach is as innovative as it is ingenious. He uses carbon dioxide, the very gas we're desperately trying to reduce, to treat this produced water. But how does this process work? Well, it's a bit like playing matchmaker. The CO2 is introduced to the produced water, and it reacts with the minerals present in the water. This reaction results in the formation of carbonate minerals, which can be easily separated from the water. This leaves us with two valuable resources: clean water and a wealth of precious elements. Now you might be wondering, what kind of elements are we talking about? Well, the list includes lithium, rubidium, cesium, gallium and platinum group metals, as well as abundant quantities of sodium, potassium, magnesium and calcium. These aren't just elements. They're the building blocks of our modern world, used in everything from smartphones to solar panels. And the best part? This process isn't just profitable, it's sustainable too. By using CO2 to treat produced water, we're not only recovering valuable minerals, but also producing fresh water for agricultural use. It's a win-win situation, turning waste into wealth while helping to reduce our carbon footprint. In the next chapter, we'll learn about the environmental implications of this technology. Don't miss it. Subscribe to Green Tech Goals. The implications of this technology extend beyond economic gain. The environmental impact could be monumental. Imagine a world where we don't just reduce waste, but transform it into something valuable. That's the potential we're looking at with the treatment of produced water. The environmental benefits of this technology are vast and multifaceted. Firstly, let's talk about waste reduction. Every day, millions of barrels of water are produced from oil and gas operations, particularly in regions like the Permian Basin in Texas. This water, once used, becomes a waste product, a byproduct of our insatiable need for energy. But what if we could repurpose this water, treating it not as waste, but as a resource? The technology being developed by researchers like Dr. Samoué does just that, turning a problem into a solution. Next, consider carbon dioxide, a greenhouse gas that contributes significantly to global warming. This technology uses carbon dioxide to treat produced water, effectively recycling this harmful gas and putting it to good use. It's a win-win situation. We're tackling two environmental issues at once. But the benefits don't stop there. The treatment process doesn't just extract valuable minerals from the water, it also produces fresh water that can be used for agriculture. In a world where water scarcity is a growing concern, this is no small feat. Every drop of water we can save, every drop we can repurpose, is a step towards a more sustainable future. So we're not just talking about transforming waste into wealth, we're talking about a shift in mindset, a new way of looking at the resources we have and how we can use them more efficiently and sustainably. We're talking about a technology that could revolutionize industries, that could change the way we think about waste and resource management. In our final chapter, we'll look at the future of this technology. You won't want to miss it. Subscribe to Green Tech Goals. The future is here, and it's bright with possibilities. Let's look at the potential future of produced water treatment. As we delve into this exciting frontier, we begin to see a world where waste is not just waste, but a source of untapped potential. A world where billions of barrels of produced water from oil and gas operations could be transformed into a treasure trove of critical minerals and fresh water for agricultural use. But as with any pioneering venture, scaling up this technology to a global level comes with its own set of challenges. There are logistical hurdles to overcome, such as the transportation of produced water from remote oil fields to treatment facilities. There's also the technical challenge of how to efficiently extract the vast array of elements present in the water. And let's not forget the economic aspect. While the minerals found in produced water can be more lucrative than the oil itself, the cost of reclamation needs to be offset. Yet, despite these challenges, the potential rewards are too significant to ignore. Imagine a world where the oil and gas industry not only provides energy, but also contributes to the supply of critical minerals for national economies, and even helps to alleviate water scarcity. Furthermore, the environmental impact of this technology is considerable. By treating produced water, we could mitigate the environmental risks associated with its disposal, turning a waste management issue into a solution for resource recovery and water scarcity. The path to this future may be fraught with obstacles, but with continuous research, innovation, and the collective will to make a difference, we can turn these challenges into opportunities. The potential is vast, the possibilities are endless, and the future of produced water treatment is indeed bright. We hope you've been inspired by this glimpse into the future of green technology. What would you like to see next on Green Tech Goals? Leave a comment below, and remember to subscribe so you don't miss out on our next exploration.